Hi, this is Dr. Graves, and this is a video tutorial to help students learn to calculate the market potential model and the aggregate travel model. They're reasonably simple. If you are in one of my classes, you've probably already completed a very similar exercise. Most of this is set up for you, so hopefully it won't be too difficult. In this scenario, what we are going to try to do is to locate a library in the San Gabriel Valley. And you notice that we have some cities here and their population here, and here's the population. And this is a distance matrix that has the miles between each of the zip codes centroid points. In order to use them to find the best place to put a library, what you want to do is to put it in the location that maximizes the chances that visitors will come to check out books at the library. So we're looking at two things essentially: the population of each of the zip codes and the distances between each of the zip codes and each other. We will calculate this formula, and the maximum value will be declared the ideal location to place the library. Here's how to do the calculation. First thing you want to do is place your cursor in cell E26. You want to type in here the first part of the formula, which is the population of city J, which in this instance is Altadena. And we're going to press the F4 key once, twice, 3 times, so the column D reference is frozen, and then we'll just hit the division sign and click up in our distance matrix on the cell that contains the distance between zip code 91001 and 91001, and that's 1 mile. If we press enter, we will get a value that is equal to the population, and that's correct. Next, press Control C for copy and highlight all the cells that are white in this area for formulas, and press enter, and that we get a value in each of the columns, which is the sum of the populations divided by the distances between that city and each of its neighboring cities or zip codes. Now all you have to do is get a sum for each of the cities, copy that across the rest of the columns, and the city or the zip code with the maximum value is the ideal location. In order to help you identify the maximum value from a large number, one of the tricks you can use is to type in equals max and highlight the data. There's only 26 rows or something, or columns today, so it's not difficult, but if you were working with many rows of data, that was how you would want to do this. So now we can identify that, but we can also add another little trick here. So highlight your rows and click on your row of data and click on conditional formatting and go to highlight cell rules and choose equal to, and it's going to ask you, well, what do you want to highlight that is equal to what? And then I'm just going to select my value for max here in cell C46 and click OK. And now we notice that there is a value that appears different than the rest, and that is the best place to put the library. Next, I'm going to scroll down and engage this formula, which would suggest, which we would use if we wanted to put a bookmobile or a warehouse, something that is located centrally where it's the library's responsibility to deliver to each of the customers every single day. This is different than, because we're not having the customers come to us, we're making the deliveries now. So what we're looking for in this instance is the minimum travel cost, or the minimum distance that we would have to travel on a regular basis in order to serve the library patrons. This formula is also reasonably simple to calculate. Rather than dividing by the distance, we're going to multiply by the distance. So once again, press equals, collect the value for the population, press the F4 button 3 times so that the $ is in front of the column reference, which in this case is D. Press asterisk for multiplication, and then go up to the distance matrix and click in the cell that corresponds to the distance between the two zip codes. Press enter, and you have a number that should equal the population of the city in the upper left hand corner of this matrix. Press copy, and once again fill all the cells in white in this calculation field. Press enter, and now you have a sum of a column that you have to create, and it's very similar to what you just did before. Sum the values in the column, and then copy that across to the adjacent rows. Press enter, and once again we are looking for a special value, but this time it's the minimum. So in order to do that, it's min, and highlight the selected cells or the desired cells, press enter, and now you have a minimum value. We're going to use conditional formatting again in order to find the special or smallest value. We're going to click highlight cell values and click equals, and once again we want to select our minimum value, and then perhaps this time we could make it green rather than red, and click OK. Now we find that Pasadena zip code 91104 has the minimum aggregate travel cost, and that this would be a good place to locate a warehouse or the bookmobile that had to make daily deliveries to each of the patrons' zip codes. That concludes this video tutorial. Please see your instructor if you have questions